Hello everyone. Today I'm going to talk about IEC62439-3 and IE1588 over HSR to HSR coupling. The IEC62439-3 has three different editions. Edition 1.0, there is no 1588 on it. Edition 2.0, this is the first edition, mentioned 1588 and C37238. The edition 3.0 is the latest edition. There's the second time to mention 1588 compared to 2.0 is some improvement regarding 1588. How to implement 1588 over PRP HSR network. IEC62439-3 edition 3.0 was released March 2016. It's named Industrial Communication Networks, High Availability Automation Networks, Part 3, Parallel Redundancy Protocol, which means PRP, and High Availability Seamless Redundancy, which means HSR. In this series video, I'm going to include 5 different parts. First one is the summary. Second one, 1588 over PRP network. Third one, IE1588 over HSR network. The fourth one, IE1588 over PRP HSR coupling. But the current one, we are going to focus on 1588 over HSR to HSR coupling. IEC62439-3 edition 2 and 3 regarding HSR, almost same. Here is the HSR network, is ring topology. For the unicast traffic, for example, this is the source, here is the destination. The traffic, how traffic sends out going through HSR network to the destination. The source send frame out going to HSR red box. The HSR red box send it out 2 different copies to 2 different directions. First one called A direction, second one called B direction. The frame on the A direction and the B direction exactly same, except HSR tag. Then the A direction has same this frame coming from network A, but frame B saying the frame coming from network B. So the A direction, frame A going to this direction, frame B going to another direction. That's the red box destination host connected to will receive exactly 2 copies of this frame. We call frame A and frame B. The only difference between 2 frames is the HSR tag. After received 2 copies of frame, this red box forward the first frame, maybe coming from A direction, maybe coming from B direction, depends on which one is arrived first, and then discard the second one. The red box right here to forward the frame to the destination. This is how does the HSR works. So this destination receives the frame from the red box. So the receiving side only receives one single frame because the second copy of the frame is discarded by the red box. Another scenario is called quad box. The quad box can connect 2 different HSR rings together. In order to improve high availability, usually use 2 different quad boxes connected to 2 different HS rings. The source host sends out frame going through the HS ring number 1 and via 2 different quad boxes to the second HS ring and then forward it to the destination. The frame sent out from source host. The red box connect to the source box host. Send 2 copies, frame A and frame B, to the 2 different directions. So this frame to the direction A and this frame to the direction B, going through 2 different quad boxes forwarded to the second HSR ring. Still the frame A going to this direction, frame B going to this direction. The red box which connect to destination host receive 2 different 2 frames. This frame A and frame B exactly same except HSR tag. The frame A is coming from network A, frame B is from network B. When the red box receives 2 different frames, just forward the first frame, maybe from direction A, maybe from direction B, depends on which frame coming first, and discard the second one. The red box just forward the frame to the destination. This quad box connect to different HS rings. IEC62439-3 edition 3.0 Annex A. This whole chapter focuses on clock synchronization over redundant paths, which means the 1588, how 1588 works over PRP HSR network. Here are 8 different chapters. Chapter 1, the overview. Chapter 2, attachment to redundant lines by boundary clock. Chapter 3, attachment to redundant lines by doubly attached ordinary clocks. Chapter 4, PRP mapping to PTP. Chapter 5, HSR mapping to PTP. Chapter 6, PRP to HS mapping. Chapter 7, doubly attached clock model. Chapter 8, PTP datasets for high availability. From this chapter list, we cannot find one chapter mentioned HSR to HS mapping, which means the HSR to HS mapping is a special case for HSR mapping to PTP. The chapter number 5, HSR mapping to PTP. Compared to regular traffic to the PTP, for the regular network traffic, the operating mode of HSR is that Dan H sends same frame in both directions into the ring, prefixed with HSR tag containing a sequence number. Each Dan H relays the frame until it reaches source again, or it's otherwise discarded. Destination Dan H therefore receives 2 frames. Use first and discarded the duplicate, which means forward the first frame but discard the second frame. Here is the regular traffic forwarded from source to destination. Frame sent out from source host, and the first red box sent out frame to 2 different directions. The frame forwarded in the direction A and the direction B, and going through code box to the second ring, and the red box connect to destination host will forward the first frame and discard second frame. The frame A and frame B are exactly same except HSR tag. This one we discussed how regular traffic going through from source host to the destination host. But now we are going to talk about PTP traffic. How PTP traffic going through the HS ring. For the PTP traffic, ground must connect to the HS ring via red box. This red box may be running as a transparent clock or boundary clock. Dan H shall implement as a hybrid clock made of transparent clock and optional ordinary clock. Quad box should be running as transparent clock. HSR node may operate with one-step or two-step clock. Red box forward PTP message to the two different directions. Then H shall handle all PTP messages for each port separately. Contents of all sync follow-up messages are different due to correction field because the message going to different paths may have a different delay. A clock shall apply BMCA algorithm on the port A and the port B. The HSR node may be either slave or master. Such HSR node may implement at TC or BC between interlinked port and ring. Here is the node. TC only, then H have to be considered. Here's how the PTP traffic going through from grandmaster to slave. The grandmaster sends out sync message. The first red box running as boundary clock or transparent clock will forward sync message to two different directions, direction A and direction B. And all the sync messages going through the two different quad box to the second HSR ring. The red box running as transparent clock or boundary clock, which connect to the slave clock, receive two different frames, two different sync messages. It's called sync message A and sync message B. These two sync messages not same as regular traffic because the correction field, the value are different compared to sync message A and sync message B. The red box, the receiving red box based on BMCA forward the best sync message to the slave clock. This is very important. Sync message A and sync message B are not same because the sync message A may go to this way and the sync message B going to this way, but two paths has two different time delay. This is all the content today. Thank you for watching the video. Bye bye.